So if digital systems are much better than analog systems, then what is the need for analog? So unfortunately, we cannot ignore analog systems. That's not the case because all real-time signals are analog signals. So analog is here to stay. However, digital is cheaper. As mentioned previously, we convert an analog signal to a digital signal using transducers and some additional processing. Sometimes an analog signal might be very weak. For example, if you are acquiring data from a satellite, the signal sent out by the satellite, by the time it reaches to you, it gets very weak. Therefore, the signal is amplified and filtered. Let's see the entire process of what happens in a typical modern day application. So, if you have an analog signal, you then convert it, or you pre-process it, maybe filter it, amplify it, assuming that the signal is coming from, let's say, a satellite. You try to filter it and amplify it. Then you convert it into a digital signal using an ADC. So ADC stands for analog to digital converter. It's an electronic component which you will learn probably in your 300 classes. So you convert it into a digital signal, then you do some processing. Maybe the signal is coming from a weather satellite, so you are trying to see the weather over the location. So you captured the signal. Now you are using a computer to process the signal, maybe put it on a map or something. And then you use a digital to analog converter or a DAC. Basically, the signal is displayed on the computer screen in terms of light, right? So anything that you see on the computer is basically light intensity variation. So you have to convert it back to analog using a digital to analog converter. So technology is advancing so much that we are trying to push as much as computing into the digital domain and as less as possible in the analog domain. So any system you design today, 90 to 95% is digital and about 5 to 10% is analog. And it's not trivial. So without proper signal, whatever processing you want to try and do is simply not going to be possible. I'm not saying analog is not important. I'm just saying that more effort is put into digital domain. Compared with their analog counterparts, digital systems are slower. For example, an analog multiplier is much faster than a digital multiplier. This is because to work in the digital domain, you first need to transform an analog signal to a digital signal. After processing the digital signal, you might have to convert it back to analog. The multiple conversions consume a little time, so digital systems are slightly slower compared to their equivalent analog systems. In this course, we are going to study the building blocks of circuits and systems, typically digital systems. We are going to analyze these blocks, that is, how they are going to work, what are the inputs and outputs to this block, etc. How do you design and use these blocks in known applications? So basically, if you are given some specifications and asked to build a digital circuit, how can you build systems based on the specifications? How are you going to choose proper building blocks and how do you connect them? In this regard, we are going to study combinational and sequential digital circuits. I will explain the difference as we proceed.